Euclid's division algorithm. In this module, you will learn about Euclid's division algorithm. You may know that the largest number that divides two positive integers without leaving a remainder is called the highest common factor of the two positive integers. You may also know how to compute the highest common factor using prime factorization. It may sometimes become difficult to find the prime factors of large integers for calculating the highest common factor. An effective method to calculate the highest common factor without finding prime factors is Euclid's division algorithm. Euclid's division algorithm is named after Euclid, a Greek mathematician, and it is based on Euclid's division lemma. It is important for you to know that algorithm means a step-by-step procedure to solve a problem. Euclid's division lemma states that if A and B are positive integers, there exist unique integers Q and R that satisfy the equation A is equal to B, Q plus R, and R is greater than or equal to 0 and less than B. Now let us consider an example to understand Euclid's division algorithm. Suppose you need to find the highest common factor of 12 and 30. Make a rectangle whose dimensions are 30 by 12. Now cover the rectangle with square tiles having side length equal to smaller side of the rectangle, that is 12. Now the remaining rectangle has the dimensions 12 by 6. Now cover the remaining rectangle with square tiles having side length 6. You can see that no rectangle remains to be covered now. Thus, 6 is the highest common factor of 30 and 12. This method to find the highest common factor involves the repeated use of Euclid's division lemma. First, you subtracted the multiple of 12 from 30, leaving the remainder 6. Then you subtracted the multiple of 6 from 12, leaving the remainder 0. The divisor that leaves no remainder in this procedure is called the highest common factor of the two given numbers. Let us consider one more example. Suppose you need to find the greatest common divisor of 38 and 32. You can subtract 32 ones from 38 so that the remainder 6 is less than 32. This step shows the use of Euclid's division lemma to 38 and 32. Now consider the numbers 6 and 32. You can subtract 6 5 times from 32, leaving the remainder 2. This step shows the use of Euclid's division lemma to 32 and 6. Next, consider the numbers 6 and 2. 2 subtracted 3 times from 6 leaves the remainder 0. Thus, divisor 2 is the greatest common divisor. Note that this step shows an application of Euclid's division lemma to 6 and 2. Thus, if C and D are two positive integers such that C is greater than D, then to find their highest common factor, apply Euclid's division lemma to C and D to find the whole numbers Q and R such that C is equal to D, Q plus R, where R is greater than or equal to 0 and less than D. Now, if R is equal to 0, D is the highest common factor of C and D. In contrast, if R is not equal to 0, again apply the Euclid's division lemma to D and R. Continue the procedure till the remainder is 0. The divisor that leaves no remainder in this procedure is called the highest common factor of the two given positive integers. This procedure is called Euclid's division algorithm. In this module, you have learnt about Euclid's division algorithm.